To introduce you to this problem, first of all, we have to know that the optimization of industrial processes are a requirement that must be changing over time. However, to achieve this in an effective and a safe way, we have to take into account environmental problems that are generated by toxic substances. In this case, we have to use TCE. TCE is a solvent that works in a degreaser by diffusion. In this case, transport processes are required to be able to analyze and optimize the diffusion process in order to control emissions to the environment. In this case, we have to take into account the importance of As I mentioned, environmental problems are very important, especially today. In this case, we have in our hands to prevent and control pollution. Although we have to know that this industrial revolution starts the optimization of industrial processes too, but they are increasing the use of toxic substances. In this case, transport phenomena is studying the relation of temperature and the diffusion of the solvent. This is why we have to take into account the security regulations that the company must have. The characteristics that the problem gives us are represented in the next diagram. In this case, we have that the solvent is contained in a cylinder. In this case, the cylinder has a diameter of 2 meters and a height of 5 meters. We have to know that the solvent is at the bottom of the cylinder with a depth of 20 centimeters. Also, it is important to know that the cylinder is open to the atmosphere. This is why we have to control the emissions that are represented. For the cleaning of metallic parts in the industry, a solvent can be used. In this case, we have TCE. Due to diffusivity, have to do it in an excellent and a fast way. In order to know at which temperature the system has to be, with a result of 500 grams per day, we have to calculate the saturation pressure. Also, on the other hand, we have that the concentration remains constant. Subsequently, some specific parameters are given by the problem. With these parameters, we can calculate the diffusion. With all this result, finally, we can calculate the flux using Fick's law. In this case, we have to know that the problem depends totally in the temperature. With the result, we can transform it to have the result of the temperature. In order to solve this problem, it is necessary to use a mathematical model related on transport processes, in which various known equations and parameters are used in order to find the result. First of all, the greatest amount of data that is useful must be identified. These parameters are shown in this table. Here we have molecular mass, density, radio, height, temperature, are constant, length, area, etc. Subsequently, the fraction of TCE in the system is calculated using an equation. Here we have the saturation pressure of TCE. To know the concentration of the vapor, it is assumed that it acts in an ideal, and the ideal gas equation of the concentration is cleared. After that, the values used to know the diffusivity result can be calculated by the Hirschfelder equations. Since sigma and epsilon parameters of Lennard-Jones parameters of the solvent are not found, this must be calculated as non-polar substances using data retrieved from NIST. Subsequently, interpolate the dimensionless temperature found to know the value of the collision integral. With all this data known so far, calculate the flux of the system using Fick's law. And finally, transfer the necessary units and find the result in terms of mass flow, and thus able to the maximum temperature. The result is 313 Kelvin. That is the maximum temperature at which the system must be found in order to comply the emission regulation. It is necessary to know some concepts of transport phenomena. Finally, the thesis is confirmed. Transport phenomena are necessary to have the result. This was through a methodology. This methodology shows us how depends the flux on the temperature, and the result was 313 Kelvin. That was the maximum temperature of the system.